Welcome back everyone, Patrick here, and in this video what we're going to do is cover analyzing quantitative variables, more specifically through the use of histograms. And we're going to do an example in this video, but before we get into the example, I want to bring back that higher level diagram that I went over in the video where we described the difference between individuals and variables in statistics. So to do a quick little review, individuals, the object that's being analyzed, usually they're going to have some kind of characteristic or set of characteristics that we're looking at, which are called variables. And variables are split up into two classes. So we can have a categorical variable, which is usually described with words, quantitative variable, usually described with numbers. So what we've covered so far is categorical variables in the previous videos. And we went over pie graphs, bar graphs, the difference between them, how we can't always use a pie graph if those categories aren't mutually exclusive, etc., etc. And so now what we're doing is moving on to analyzing quantitative variables of individuals. And as I mentioned, there's two tools that we can use to analyze quantitative variables, histograms and then stem leaf plots. And what we're going to be covering in this video is analyzing a quantitative variable through the use of a histogram. So let's show how all this works through an example. So what we got to do is we got to create a histogram for the percentage of people in each of these cities here that are using iPhones. So what this means is that 61% of the people in Toronto are using iPhones, 50% of the people in New York City are using iPhones, etc., for the rest of the cities. Now notice that this table is pretty big, so if you don't want to write it out, it's in the lecture notes, so you can find them at the beginning of the section on the website. If you're watching it on YouTube, you can click the link in the description box and it will take you to the lecture notes. Now, one thing I want to mention in this example, a couple things actually. First thing is, notice how the cities are the individuals that are being analyzed. Remember, individuals are the objects that are analyzed, whether they are people, places, or animals. That's usually what they are. So notice we're dealing with places here. We're dealing with cities. And then these individuals here are represented with this characteristic that we're looking at, the percentage of the population that is using iPhones. And notice that this characteristic or this variable is represented with numbers. So it's a quantitative variable. If it was a categorical variable, it would be represented in words. Right? So this is a quantitative variable here. So we're going to be using a histogram, because remember that's a tool used for quantitative variables. Now, before making the histogram, I actually want to differentiate between a bar graph, mention some brief differences between a bar graph and a histogram, because when you look at them initially, they are very similar, but when you go into more detail, you start to notice all the differences. So remember, a bar graph on the y-axis, we had the frequency, or the number of individuals, or the percentage of the individuals in the data we were analyzing that fell into certain categories. And we had the categories here on the x-axis. So we would have like category 1, whatever it was, then we had category 2, etc., etc. Some of the examples we went over was like majors in the classroom. So we had like math, science, arts, English, or we had the fruits that people ate in the past month. We had like a banana, apple, etc., etc. And notice that each of these bars here, there was a space between all the bars, meaning that each of these categories was separate, which makes sense. And then for each category, the height of the bar told us the frequency or the number of individuals for that data in each of those categories, or the percentage of individuals in each of those categories. Now, a histogram, very similar. The y-axis is going to be the frequency as well. It's going to be the number of individuals. But remember, histograms are used for quantitative variables, not categorical variables. And so what the x-axis for a histogram is going to be, it's going to be the quantitative variable that you're looking at, or the characteristic that is represented by numbers. So it's going to be the quantitative variable broken down in intervals. Right? Some other words for these intervals, you'll sometimes see it called classes. Sometimes you'll see it called bins. So basically what's going to happen is we're going to take a quantitative variable. We're going to take its lowest amount in the data, and then its largest amount, and then we're going to break it down into even size intervals. Each of these intervals are going to be the same width. And then what we're going to do is we're going to count the number of individuals that we're looking at that fall into each of these intervals. So maybe this first interval is going to have this many individuals, and then this interval here is going to have this many individuals, and then et cetera, et cetera. Okay, it's going to look something like that. That's an example of how a histogram is going to look. So notice that there's no space in between the bars, because this here is going to be a continuous scale. It's not going to be categories, it's not going to be words, it's going to be actual numbers. It's going to be from the smallest value to the largest value, or from the lower bound to the upper bound. And then the smallest number usually is going to be in this first interval, and then the largest number in the data is going to be in this interval over here. Right? So it's going to be continuous, so these bars aren't going to have any spaces in between them. Right? So just wanted to mention that, some brief differences between the two. Remember, bar graphs for categorical variables, histogram for quantitative variables. Okay, so now let's actually show how to make a histogram given data like this. So the first thing I personally like to do is I like to look at the quantitative variable and find the smallest amount and then the largest amount. So notice that the smallest amount out of all these is this 42 over here. And then the largest amount of all these is this 91. Right, so it's going to be fluctuating between 42 and 91. All of these quantitative variables are going to be in this range over here. So then what I like to do is I like to look at this and then create the number of intervals that I'm going to use. And this is purely judgmental. It's all up to you. With experience, you'll get better at picking how many intervals you should be using. If you're using a software, usually they're going to pick the correct amount so that shape of the histogram can be analyzed correctly. And actually at the end of the video, what I'm going to go over is the effects on a histogram if you pick too few intervals or if you pick too many intervals. What's going to happen to the histogram and why it's hard to tell its actual shape. So 42 to 91, what I'm actually going to do is go up by tens. So the intervals that I'm going to use, I'm going to go 40 to 50, then 50 to 60, then we'll do 70, or no, sorry, 60, we can't skip anything. We'll do 60 to 70, then we'll do 70 to 80, 80 to 90, and then we'll go 90 to 100. Just notice this last interval is going to have that maximum amount of 91. Now, what's the problem with these intervals that I picked? Well, if we take this 50 here for New York City, which interval is it going to fall in? Because notice we have 40 to 50 here, and then we have 50 to 60, so that 50 is coming up twice. And so this is actually not correct to do. What you need to do is instead of saying 40 to 50, you would say 40 to anything less than 50. And then 50 to anything less than 60, and then less than 70, less than 80, less than 90, less than 100. And then there's never going to be an individual that falls into multiple intervals. So this 50 here would go here, because notice this interval is 40 to any numbers that are less than 50. Now another thing you can't do, a common mistake, you can't do like 40 to 49 and then 50 to 59, for example. Why? Well, notice that all of these percentages are nice whole numbers, but a lot of times you may be dealing with decimals. And let's say that one of these was like 49.98%. Then which interval would it go into? Notice that it's neither of these intervals, because 49.98 is greater than 49, but it's less than 50. Right? So it has to be right up until that 50, up until to 49.99999, all the way to infinity, an infinite amount of nines, just to make sure that everything is getting taken into consideration. All right? So this is the proper way to do it over here. So this here, these intervals, is the percentage of the population with iPhones. And then this here is going to be the number of cities. And so now what we got to do is just tally it up. So let's start with 40 to less than 50. So notice that Montreal would be there. So that's one city. And then notice there's also this 49. There's no other ones. So there's two there. Let's do 50 to less than 60. Notice that NYC would be there. Miami, 58 would be there. And then San Diego, 53 would be there. And then that's it for that interval. Then we'll do 60 to less than 70. So notice that we'll have 1, 2, 3, 4, 5, 6, 7, 8. So we'll have 1, 2, 3, 4, 5, 6, 7, 8 in that interval right there. 70 to less than 80, if we go through all of these, notice that there is none over here. Same thing with 80 to less than 90. There is none in those two intervals. So those are 0, and then this 91 would be in this final interval, this 90 to less than 100. So that there is the frequency table for this data over here. So now what I'm going to do is I'm going to take this frequency table and make a histogram with it. So let's draw out these axes here. Now remember, this x-axis, it's the quantitative variable broken down into intervals. So the x-axis here is going to be the percentage of the population with iPhones. And then the y-axis is going to be the frequency. In this case, the number of cities. So what we got to do is we got to plot these intervals on the x-axis. So we'll have, let's start with 40 over here. You don't have to start at 0. You could just start the lowest amount of the first interval somewhere to the right of that y-axis. It doesn't have to be right on that y-axis. So we'll start with 40 there, then we'll go 50. So we'll have 40, 50, 60, 70, 80, 90, 100. 60, 70, 80, 90, and then 100. Now, this first interval, I want to mention, remember, it's not going to include the 50. It's going to be all the numbers that are less than 50. And then this second interval here is going to be 50 to all the numbers that are less than 60. So even though it's ending on 60, this interval here, it's all the numbers that are less than 60. And then this third interval is starting at 60. So that's one thing I want to mention. And then the y-axis, notice the maximum number is going to be 8. Minimum number is going to be 1. So let's go up by 1. So we'll have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And now what we got to do is just create those bars for each of these intervals. So notice 40 to 50 was 2. So that's going to be like that. And then 50 to 60 was 3, which would be over here. 60 to 70 is 8, which is going to go all the way up here. Notice 70 to 80 and then 80 to less than 90, these are 0. So there would be no bars here. And then 90 to 100, or 90 to less than 100 would be 1, which would look like that. Okay, so that's one point I want to make. Whenever there are empty spaces in a histogram, it's not the same as a bar graph. Remember, we're not separating the bars. So if there is an empty space, it just means that there is 0 frequency or 0 individuals in that interval for a histogram, because there shouldn't be any spaces between the bars. So if there are spaces, just means there's 0 in that interval, a 0 frequency. Also notice that this here is sort of kind of isolated from most of the data, right? So that was San Fran, where 91% of the population is using iPhones. So you may want to analyze this. This might be an outlier. So just an example on a histogram where you can identify outliers if they are really separated from the bulk of the data. Notice all the bulk of the data is here, and more specifically, most of the cities are in this interval here between 60 and 70%, right? Where 60 to 70%, or 60 to less than 70% of the population is using iPhones, right? So that there is a histogram. So again, the biggest difference between a histogram and a bar graph has categories here, and the bars are separate. And then a histogram, that quantitative variable is broken down into intervals. Now, I want to end this video by talking about, I mentioned I would talk about this before, where what if we picked fewer intervals? So instead of going up by 10s, what if we went up by 20? So what if we went like 40 to 60, then 60 to 80, and then 80 to 100? Well, if you have too few intervals, what's going to happen is your histogram, it's going to start having like, it's called like a skyscraper effect. So it's going to be too narrow and too high, right? The data is going to be too narrow, and then all these bars are going to be more high, right? Because these intervals are just going to be bigger, so there's going to be a larger frequency in each of the intervals. Sometimes, again, if there's too few intervals, it's called the skyscraper effect. And notice how this kind of looks like the skyline of a city. This does too, but notice that this data here is just better spaced out. It just looks nicer and it looks better to analyze. So for example, notice here how we were able to spot this potential outlier. Well, if you have too few intervals, and so these intervals here are going to be larger, because there's going to be fewer of them, so they're going to be larger intervals. Sometimes outliers are going to get grouped with other data, and outliers would be tougher to spot if there's too few intervals. Now, on the other hand, if there's too many intervals, what's going to happen is the opposite effect on the histogram. So the bars are going to be too low, and it's going to be too wide. So what's going to happen is you're going to see something like this. Right? So instead of going up by 10s, maybe you'd be going up by like 2s or 3s. Right? Then what's going to happen is all this data, it's going to get too spread out. It's going to be too wide. Sometimes this is called the pancake effect. And so what can happen then is you may start thinking that certain data points are outliers when they're really not outliers. It's just because you're making these small intervals that stuff is sort of being shown too far to the left and then too far to the right. So if there were too few intervals, it's hard to spot outliers. If there's too many intervals, then you may think that there are outliers when really, when you look at the whole data properly, they aren't really outliers. Right? So just be aware of that, and that's why it's important to pick the correct number of classes or the correct number of intervals. Again, software is usually going to make a correct decision so you could analyze that data properly. But in case you're asked to make histograms on your midterm or exam, make sure you get enough practice in picking that correct number of intervals.